So we were discussing about solid waste management system (SWM system), and we have described the functional elements and their relationship. And at the same time, what do we understand by telling solid waste management system? Now, next thing is, I just wanted to discuss, and you can hear these or you can note down the points, whatever it is, that is the factors affecting solid waste management system. So there are few factors, essentially, which influence the solid waste management system, because if the nature of the waste is different, then the entire procedure or the dynamics of the procedure also gets altered. And that is why we need to understand what are the factors which affect the solid waste management systems. Now, the first one, if I talk about, is the quantity and characteristics of the waste. And so basically, the entire solid waste management systems depends upon how much quantity and the characteristics of the waste which needs to be handled or managed. So quantity is the first aspect, and characteristics of that waste is the second aspect. Now, depending upon the characteristics, you can chalk out which treatment procedures need to be adopted, and up to what extent it has to be adopted, and things which really matter to define this quantity and as well as characteristics are nothing but the lifestyle income level of the family, and at the same time, the so mostly this is one aspect which we can see, this lifestyle and income. For higher income group, the generation of the waste is also higher, or the quantity of the waste is also higher compared to the low income group, and the quantity ranges from about 0.25 to 2.3 kg per person per day. Now see the difference and contrast, you will be able to understand that how they are significantly going to affect the overall solid waste management system. Now, apart from that, one of the measures of waste composition is density, and that also ranges from 150 kg per meter cube to 600 kg per meter cube, depending upon the what are the composition it is consisting of. Now, different proportion of the paper packaging material with other metals actually alters the overall density, and that is why if you see overall, the quantities and characteristics is one of the predominant factors which can change the solid waste management. Next is the climate and seasonal variation. Before also we have discussed several times, in overall generation of wastewater, there is a significant role of the climate and seasonal variation. Similarly, when we talk about waste management, there is a huge role for the climate and seasonal variation to play. Suppose if you see in cold climates, drifting of snow, frozen ground interfere with the landfill operation, and therefore trenches must be dug in summer to cover the material or stockpile for the winter use. Now, on the other hand, in case of tropical climates, what happens is you will have very sharp seasonal variations from wet to dry, and as well as as far as temperature is concerned, you can encounter huge higher temperature during the summer and very low temperature during the winter. And at the same time, you will have significant changes in the moisture content of the solid waste, varying from less than 50% in dry season to greater than 65% in the wet months. So you will have a change in the moisture content up to 15% or more than that. So that is just quite significant when you are dealing with million tons of solid waste. And that is why collection and disposal of wastes, when it is wet, is really problematic. On the other hand, what happens is this seasonal and climatic variation will have significant effect on the decomposition decomposition dynamics of the waste. In higher temperature and humidity, cause solid waste to decompose far more rapidly than they do in the colder climates. And that is what actually I'm talking about. Since the entire thing is dependent on the activity of the microbes, so depending upon the temperature, we may have different type of microbes, and most of the microbes can do their activity comfortably in the higher temperature and humid situation. On the other hand, if you have very low temperature, the decomposition rate will be slower, and this can be related to what you see in the refrigerator at your home. So you put your cooked food in the refrigerator, and then there is you can get the fresh food next day also, and that is basically because of that less temperature, the decomposition rate is very slow, or somehow uh, the decomposition rate is stopped by manipulating the temperature. And same you can observe in case of here in naturally, when you have temperature which is close to 0 degree, the decomposition rate will be very less compared to when it is in the tropical region, like 30-40 degrees centigrade temperature with some humidity. So that is why, if you see holistically, the effect of seasonal and seasonal variation and temperature change, at the same time climatic variation, which can cause change in the moisture content and humidity. So that has significant role to play in the solid waste management systems. Apart from that, we have physical characteristics of an urban area. See what kind of town it is, how many vehicles daily run in that particular locality, and what type of solid waste they are going to collect. As far as management is concerned, whether that is a big vehicle which can compact the waste, or it's a small vehicle, simply it will carry the waste to the transfer station. I mean, those things you need to see. Apart from that, if you have a disposal facility, how far it is, or so those things needs to be understood in the aspect of physical characteristics of an urban area, so that if you have a change in this factor, then there will be a significant change in the overall solid waste management system. Next is financial and foreign exchange constants. So what happens is, there will be a budget for the solid waste management for each and every municipal corporation. And this is what is actually you know uh, the overall whatever capital resources particular municipal corporation would have, and some percentage of that will be allocated to be utilized for the solid waste management. Now, if there is a constraints as related to foreign exchange or any financial limitation, if it exists, then that effect will be there, and then that can reduce the overall efficacy in the management of the solid waste. Suppose if you have a cartel in the overall capital resources, then the instrument which needs to be procured to process or manage that much amount of waste will also be changed. So the waste management or rate of waste management will change, and thereby there will be a difference in the overall efficacy. So that is why this aspect is also important. Next come cultural constants. So depending upon the culture and community, you can see that the generation of waste can also be different. The characteristics of waste also can be different. So this can also be related to the solid waste management systems. And mostly these are the different factors which I wanted to mention. And now if we go to the next flow chart, we'll be able to understand the overall waste generation steps. So what happens is, the main idea is, once you take a raw material for anything, for any activity, so from that raw waste material you may have some amount of residual, and that can be called as waste. Now, that raw material goes in the primary manufacturing component, and from that primary manufacturing component, again you will yield some amount of residual raw material, and that can be related to the uh, you know mm, waste, or which is not desired. Just 1 second, hold on for 1 second. Hello. Good morning. हाँ हाँ। अच्छा ठीक है, मेरा क्लास चल रहा है, क्लास के बाद मैं आता हूँ, ठीक है। 11:30। Yeah. And then comes your secondary manufacturing. Now there is a cycle. From secondary manufacturing, you can have the processing and recovery of the waste, or and then again you can send it to the primary manufacturing. Or sometimes what happens is after processing and recovery, again directly some amount of material can be directly sent to the secondary manufacturing. Now, from the secondary manufacturing, a component goes for the consumption. So that is what is mentioned as consumer, and from there again it goes to the processing. Now, from the processing, either it goes to the manufacturing or in the secondary manufacturing, and by the process, you get some amount of material which is not desired, and that is again can be called as waste. Similarly, some components from the secondary manufacture can directly goes to final disposal, and when you have processing and recovery, from there also some amount is not suitable for any other steps, so then that can also be sent to the final disposal. So this is the way overall waste generation can be linked with how we can use them, in how many iterations we can use them. Those things can be understood from here in this particular uh, flowchart. So this is a table which basically showcases the typical composition, moisture content, and density of Indian solid waste, municipal solid waste, especially, and you can see their range, and as well as the typical value, and you can see the mass percentage, moisture content percentage, and then we have the density. So what you can do is you can have an idea about what are the different type and how much is the in municipal solid waste, what is the predominant component. So mostly if you see, we have food waste and paper, and depending upon, sometimes we can have some amount of cardboard, and then the next one which we can get in more percentage is garden tinning. So that is also organic, we would say. Next comes in few cases you will have glass materials and tin can, or tetra pak can, or ferrous material. These days, that the percentage of plastics is increasing in alarming rate, which needs to be considered, and which needs to be reduced to practice sustainable engineering. So I am showing this table to have a good idea about what are the compositions associated with Indian municipal solid waste. Now we'll be talking about the storage of the solid waste and how this procedure is done and all. So why municipal solid waste storage is important? Because if you see, there is a significant time lag between the generation of the waste and processing of the waste. So within that, if you don't have proper facilities to store that solid waste, then that will actually have several detrimental impact on the environment. And to reduce that, or to avoid that, we should have proper solid waste storage facilities. And that is why we can see, we have mentioned over here that storage is a key functional element, and that is actually that we can say from the what we have seen in case of the previous flowchart. Fine. So there we can see that we have storage, which is a very significant component of the solid waste management. And waste generated in residential areas must be removed within 8 days due to shortage of storage space and presence of biodegradable material. So we have potential material, and if you keep more than 2 days at your home, like how unpleasant those smell can be, or it can stink very badly. So you cannot stay at your home. So that is why we should have some facilities to store that. On-site storage is of primary importance due to aesthetic consideration, public health, and economics involved. Now we have a lot of domestic or we have stray animals which actually create nuisance if you throw solid waste without covering it or without having proper isolation. So those will be simply spread off in the environment that will uh, affect the aesthetic aspect of the city or the locality, and that will significantly influence the public health and overall economics involved, because once these are all spilled over, then some manpower is required again to gather them and then simply carry to the big municipal solid waste carriage truck or any other vehicle. So for that also you need some amount of extra money, and that is why economics is also involved. Now some of the options for storage are plastic containers, conventional dust bins, used oil drums, large storage bins. So and at the same time, if you just simply try to see at your locality, you will see that in many places there are concrete compartment in which waste are supposed to be dumped, because in earlier days that is the way waste used to be collected. But now the problem is, as I have mentioned, because of mostly because of the stray animals, we don't prefer to store waste without having proper cover. So that is why containers and storage bins have gained a lot of population in the last decades. So go to the next page. So we have solid waste storage facilities, we have containers and storage bins. So storage bins can be of two types. One is stationary containers. So these are the containers which are used for contents to be transferred to collection vehicle at the site of the storage itself. And then we have hauled containers. So in this case, these are used for contents to be directly transferred to the processing plant. Now transfer station or disposal site for emptying before being returned to the storage site. So these are the different type of containers. Then we have communal containers. So basically in the right hand side you can see that green colored container. So that is basically the communal container. So these communal container are filled, and then once a compactor collection vehicle comes, so that communal container can lift up and can be emptied mechanically. Fine. Now these the use of communal containers is largely depend upon the local culture, tradition, and attitude towards the waste. And communal containers may be fixed in the ground, or it can be movable sometime. And movable containers are provided with hoists and tails compatible with lifting mechanism, so that directly municipal vehicle come and lift up those containers, and they can again drop another one empty container. Usually these communal containers will have a volume of capacities of 1 to 4 cubic meter, and the waste management authority must monitor, maintain, and upgrade the communal containers. And you can see these are very common, and these communal containers are often made up of concrete. In the old cities you can see in concrete form, and that is what actually I was talking about. The main problem with the concrete communal containers is that it will not be having any cover, and which is what is not desirable. And then comes the collection vehicle. Collection vehicle is also a very important components of the solid waste storage and handling. So we have different type of collection vehicle: small scale collection vehicle and muscle powered collection vehicle. So these are the common vehicles which are used for collecting waste, and in most of the district, town, or small cities, or even in areas, you can see that these small scale collection or muscle powered collection vehicles are being used. These can be small rickshaw, carts, or wagons pulled by people or animal. And they are less expensive, easier to build, and they can be operated in the narrow roads as well. And next comes we have the next is the non-compacted trucks. So that is the second type of collection vehicles. So non-compacted trucks are efficient and cost-effective in small cities and in areas where wastes tend to be very dense and have little potential for compaction. And once you have, in left hand side we have this non-compactor trucks. You can see left hand side bottom, and these compacted trucks are actually non-compacted trucks are mostly preferred in a city where you have narrow lanes and where preferably you don't need uh, compaction of the waste at the site itself. So in this kind of here, the capacity of this truck is 10 to 12 meter cube, and it can actually carry 10 to 15 kilometers up to the transfer stations, from where bigger vehicle can take the waste and it compacts and then it finally take it to the disposal site. Now the third option is compacted truck. So usually the compacted truck will have a volume of 15 to 12 to 15 meter cube due to limitation, and these kind of trucks are not used or not suitable for a smaller or older town or cities because of the limitations imposed by narrow roads. You have to have wide roads, and these are the most preferred one for the planned cities. And what it can do is it can actually compact the waste itself, and it can increase the density up to 2 to 2.5 times, and it can actually carry 2 to 2.5 times of its original volume by compacting and increasing the density. And we can have different type of compacted truck. There sometimes there hydraulically, compactors will be attached, and then another one hydraulic will be attached to empty this kind of compacted trucks. So we have different arrangement for that, and most of you might have seen these kind of arrangements for solid waste storage and handling. Now the next point is solid waste collections. So this is also the next important part is solid waste collection. So we'll be discussing them. So first, what is the main points is the collection points. So first we need to talk about that. Once waste is actually taken out from the domestic area or the household, then finally it will go to the collection points. And from collection points, this waste, we need to next see the collection frequency. That means how many times in a day the vehicle will come to collect this particular solid waste which has been accumulated in that collection points. And next comes the storage containers. So the storage containers which we discussed just now, so how much would be the capacity, how much would be it will be able to take. And then comes the collection crew. So depending upon the storage containers and the collection frequency, amount of the quantity of collection points and amount of waste which will be generated, we need to see how many number of collection crew are required. And once we actually chalk out that, next we need to see the route by which we'll do the collection procedures. Now this effective routing is very important for the overall economy of a municipal solid waste management projects. So that is why the collection routes and chalking out the effective collection route is very important. And then finally you have the transfer station, where you facilitate in transferring the waste from a smaller vehicle to a centralized facility. Sometimes what happens is you have smaller vehicles which does not consist of compactor. So all those smaller vehicles will collect the waste and it will bring to the transfer station, where the waste can be compacted, and then finally it can be transferred to the bigger vehicle, and from that vehicle it will go to the disposal site. So this is the overall flow chart of the solid waste collections. And then this is the procedure I have given here. You can see that Now, so basically we have gathering of waste and hauling them to the location where the location collection vehicle is emptied, and that may be transfer station or intermediate station where wastes from smaller vehicles are transferred to the larger ones, and also segregated a processing plants or a disposal plant. So this is the steps. Now collection depends on a number of containers, frequency of collection, types of collection, services and routes, so which I mentioned before. Next is you have collection is provided under various management arrangements, ranging from municipal services to franchised services and under various forms of contracts. So you have municipal and municipality, and then under the head of municipality you may have some contractors and subcontractors who can be involved in overall activity of the solid waste management. Next comes what are the different vehicles which are to be used for long distance hauling, and that may not be suitable for particularly not suitable for house to house collection. However, they can be used for long distance hauling. Every solid waste management system therefore requires an individual solution to its waste collection problem. This is a very important statement, needs to be kept in your mind. So there is no sacrosanct provisions by which you can manage the solid waste, because if you change the geography, locations, the people, and then the weather and other things gets altered, and then that is why the municipal solid waste management system also gets changed and or get influenced. And that is why you need to develop a required solution for the waste collection problems at your locality or the area where you have been given the responsibility. So this is very important to remember. Next comes the solid waste processing. Solid waste processing is very important. Why? I guess all of you will be able to understand, because processing gives some value added what I would say is it gives some value-added products of the waste. So processing is required to alter the physical and chemical characteristics of the waste for energy and resource recovery and recycling. So this is the main important part actually I was talking about. Now, why processing is done? So processing is essentially done to improve the efficiency of the solid waste management system. Very true. Next is recovering material for reuse. So that is what actually we are talking about. So materials having a market value, and when it is present in the waste, insufficient quantity, so there will be facility by which we'll be able to separate those material, and then they can be accumulated and they can be used as a value-added product, and the rest of the material can be that value-added material can be recovered from all other type of solid waste, which include paper, cardboard, plastics, glass, ferrous metals, aluminium, tin cans, and other residual metal. So this is very important. And then you have that different process, in processing techniques, which include compaction, thermal volume reduction, manual separation of the waste components, incineration, and composting. So these are the different methods by which the processing is done. And the first one is the volume reduction or compaction. So volume reduction or compaction refers to densify the wastes in order to reduce their volume, and there are few benefits of this process. It reduces the overall quantity of the materials which needs to be handled at the disposal site. It improved the efficiency of the collection and disposal of the waste, because at a time you will be able to carry more quantity of waste by compacting them or by volume reduction of them. And then what we can do is we can increase the service life of the landfills by mechanical compaction or by size reductions. And these are economic, these are actually this enhances the economic aspect of the waste management system. However, there are few limitations of this process. So what happens is it becomes difficult to sort out or separate out a particular type of material once you compact them. It is very difficult to segregate or sort out different type of material, because it creates lump and compress capsule. So that is not good as far as separation is involved. And then what happens is biodegradable material like leftover foods, fruits, vegetables, they get destroyed. And and what happens is if you have some paper or plastic material which can be recovered, that will be spoiled because of this overall compressing process. So these are the limitations associated with mechanical volume size reductions. We have different type of equipments for doing this procedure. And next is chemical volume reduction. So chemical volume reduction is basically you take help of some chemicals by reducing the volume, and thereby by not applying any mechanical uh, you know means of mechanical energy, you can still reduce down the volume of the overall waste. Next is the air separation. Right? So what is done is you apply or you purge higher amount of. So basically, if I have to give some examples of what I mentioned just now, chemical volume reduction. So what is done is we can talk about pyrolysis, hydrolysis, or any chemical conversion. So these are the example. Next is air separation. So what is done is air separation is basically we have uh, what do we say? We have purge air, and then you have material of different specific gravity or different weight, and based on that, there will be a separation, and this particular process is called as air separation. So basically, when you have dry mixture of material, air separation can be used as the primary separate, and it separates out the lighter material, which is usually organic, from the heavier material, which is primarily inorganic. So the lighter material includes plastic, papers, and paper products, and other organic material. And generally, there is also a need to separate the light fraction of organic material from the conveying air streams, which is usually done in cyclone separator. So just try to remember cyclone separator. So So usually we have different type of arrangements by which we can do this air separation. We have conventional tube type, separator. We have zigzag air classifier. So different type of arrangements are there. Open inlet vibrator type. So different type of arrangements are there. As I mentioned. And next comes the magnetic separation. So this is also very important. And by this, what we can do is we can segregate out or separate out huge components of the waste. So that is the ferrous materials, and that can be separated out. And how it is done is we have usually two different type of system. We have magnetic pulley, we have suspended magnet. So once we pass the entire dry waste through that conveyor belt, so depending upon the nature of waste, if it is a ferrous waste, then it will be arrested in the magnet, and then the rest of the non-ferrous material will be passed through the conveyor belt. And there are two different arrangements of magnet. One is magnetic pulley, another one is suspended magnet, and these two types are used to just simply performing this task. And next is screening. So screening is most common form of separating solid waste depending on their size by the use of the one or more different more screening surfaces. Screening has a number of applications in solid waste resources and energy recovery systems. These screens can be used, before or after shredding and after the air separation of the waste in various applications dealing with both light and heavy fraction materials. And the most commonly used screens are rotary drum screens and various forms of vibrating screens. So there are several arrangements by which this screening is done, but this is a significant one, and it is usually conducted after the ear separation. And then you have hand sorting or previewing. So in many cases, we employ manpower for the hand sorting or previewing. So previewing of the waste stream and manual removal of the large size material is necessary prior to the most types of separation and size reduction techniques. This is done to prevent the damage or stoppage of the equipment, such as shredders, screens, and anything like what are the different machines which will be involved in separating or processing may get damaged if you have a higher or bigger size of material, and that is why that particular sorting is done in this type of hand sorting or previewing. Suppose you have bigger rugs, pillows, mattresses, so that can also get create some problem for those equipment to run smoothly, and that is why it is required to have hand sorting or previewing. And finally, the inertial separation. This is also very interesting type of separation. So inertial methods rely on ballistic or gravity separation principles to separate the shredded solid waste into light and heavy particles. And if you see, what is done is it is through the rotor, the waste is thrown, and then depending upon if the inorganic particles which are comparatively heavy will go the further distance, and in the nearby area the organic particles will be accumulated. So this is the way we have different type of materials which are and apart from that, you can have a sloped conveyor belt, and once the waste is actually getting dropped in that conveyor belt, the heavy portion will just simply slide down, whereas the light plastic or inorganic material, because of the friction, will go up, and then it will go to the other side of the conveyor belt. So by that also we can do the separation. And then there are few other process like flotation, optical sorting. So these are also sometimes used, but I am not discussing in detail. Next, another one aspect, uh, that is the disposal of solid. But disposal of solid will take some time, so maybe these two I'll finish in the next class. So if you see, just let me